Can you believe it? We made it to the end of Unit 2. This time, it's the review/test found in your student activity book with me, Miss Bowman. We're going to start with vocabulary. We have the words off to the right, that some of them go inside here. Blank is the amount of surface covered or enclosed by a figure. Now, looking at the right, I know it can't be any of those specific shapes, but I'm torn between perimeter and area. So when I'm thinking about perimeter, I think about that fence around. Area is the surface that the perimeter goes around. So the correct answer would be area. A or an blank is a polygon with 8 sides. So rhombus, no. Hexagon, that is 6. Perimeter, no. It's octagon. I think of oct, like an octopus, has 8 tentacles. A blank is a parallelogram with all sides the same length. So torn between, well, I know it's not perimeter, but hexagon and rhombus, well, it's going to be a rhombus. So rhombus is like a floppy square. At least that's what I think of, a floppy square. So number 4, why do you use linear units for perimeter and square units for area? Great question, math expressions. So if I'm using linear units, I would write inches. If I'm using square units, I would write inches squared. So now if I'm looking at perimeter, we talked about multiplying. Now multiplying, I'm going to be looking for those square units in between. When we talk about volume, we're going to be talking about units cubed. But perimeter is a length. So it is like lines put together, right? So when we're writing it, we use linear units because it is something where we're either adding all the sides or we're multiplying, by 2 and adding them up if they're congruent. It only has one dimension though, so think of a continuous line. Area, it's length and width, so it has 2 units that we're multiplying together, and that's how we get the square. What dimensions do you need to find the perimeter and the area of the parallelogram at the right? So now if I'm looking at perimeter, I'm looking at what's around. So it's like that fence that goes around a yard. So I'm going to need the base and the side length, or I could say the lengths, right? I have 6 centimeters and 5 centimeters. I would be doing each of those 2 times. So I'd have 5 plus 6 plus 5 plus 6. Area. Now this time I'm going to use the base, which is 6, and I'm going to use the height, which is 3. I'm using the height because that's going to really show me what's on the inside. The perimeter, those you can see at our diagonal, they're actually longer than the height. Also notice that these questions aren't asking for a total. So sketch a diagram to show why the area of any triangle is 1/2 the area of its related parallelogram. So I'm going to draw a parallelogram, and I'm going to slice it right down the middle on the diagonal. Now, if I were to find the area of a parallelogram, I would normally multiply base multiplied by height or length multiplied by width. But when I'm looking for a triangle, as it is related to this parallelogram, I'm only looking at half of it. So I would multiply that base and the height, and I would divide it by 2, and I would be able to get what the area is for half of it, in this case, the triangle. And it's always good to remember that when we're looking at math, a lot of these things build on it, right? We talked about different formulas. We just added on a little bit. It's that half from what we started with, looking at base multiplied by width or length. Why is decomposing important when finding the area of a complex figure? When I'm decomposing, I'm making sure that I'm turning multiple shapes that I feel confident and comfortable in finding the area of, that like they come from a big complex figure. I think about little parts of a transformer. So I might know what each part is, and I can find the area of the perimeter. But when I put them together, it makes this big complex figure. So it's easier for me to find the area of each smaller one and then add them up. Why do you subtract the y coordinates, not the x coordinates, to find the length of a vertical segment on a coordinate grid? This will be one of the last things we looked at in 2-9. So I'm going to draw a really quick coordinate plane. Now, this is 2, 2, and 2, 5. Notice they have the y coordinate in common. So if I'm going to subtract the y coordinates, it's because they're vertical. They share the x coordinate, meaning they're on that same vertical line. So if I were to subtract the x's, it just wouldn't make sense because I would say 2 minus 2. But if I subtract the y, I would say 5 minus 2 and find that they're actually 3 units away from each other. The x coordinate is the same for each endpoint of this vertical segment, so it wouldn't make sense to subtract them. When I do this, I like to use subtraction first, and then I do like to draw a quick little graph that helps me double check my answer. But I'm not just depending on one thing. Off to the next page. So we're going to start with number 9, and we're going to find the unknown side length. So I have an area of 28. Now I know for a rectangle like this, its base multiplied by height is equal to area. So I'm going to write it. 7 multiplied by h is equal to 28 inches squared. So what multiplied by 7 gives me 28? 7 multiplied by 4 gives me 28. So my answer is 4 inches. Number 10. I have an area of 96. I don't have a base, but I have a side length of 10 and a height of 8. Now, I'm not going to get confused with my side length and my height. My height is on the inside. So base multiplied by 8 is equal to 96. Now, I could divide 96 by 8 to find out what it is. If I decide to divide, that's fine, and I can set it up and find the quotient. Or if I am really great with my multiplication facts, I would know that it is 12. Either way, it's good to double check your answer. We're going to find the perimeter and the area for each figure. Now, number 11 is tricky because it has a triangle set up. But first thing that I need to do is I need to remind myself, how do I find the area, right? I'm using base multiplied by height. I'm going to divide by 2. So I already label that outside number h because that is my height. My perimeter is going to be adding 9, 17, and 10 and finding a sum. That's 36 centimeters. Base multiplied by height divided by 2 is the area of a triangle. So 9 multiplied by 8 divided by 2 is 72 divided by 2, which is 36. So it's a pretty cool shape that actually shares 36 as a perimeter and an area. Pretty neat. Now this one is a rhombus because it has all the sides that are equal. Now I'm going to make a note to myself that to find the perimeter, I could do 9 plus 9 plus 9 plus 9. That equals 36. I could also do 9 multiplied by 4. So my area, it's on the inside. Again, base multiplied by height. It's a rhombus, so I don't need to divide it, but they're going to try to be tricky with me by tilting it this way. So I multiply 9 by 7, and I get an answer of 63. So I get an area of 63 feet squared. Number 13. This is a trapezoid. Well, it could be a trapezoid, or it could be a triangle and a rectangle. So 4 plus 10 plus 5 plus 7, that's equal to the sum of the numbers, which is the area. And I can add it up in 14 plus 12, which is 26 centimeters. Now, things I could do. I could split this up. So if I want to make my sides congruent, my top and my bottom, they would be 7. But I know that total length is 10, so I have 3 left over. That must be the base of my triangle. The middle is 7 multiplied by 4, which is 28 centimeters squared. And the triangle has a base of 3 and a height of 4. So 4 multiplied by 3 divided by 2, because it is a triangle and we have half of a quadrilateral. So that equals 6 centimeters squared. I can't just leave it at 28 and 6. I need to add it together. So 28 plus 6 is equal to 34 centimeters squared. This one, number 14, is a little bit more labor intensive. I'm actually missing a couple numbers that I need to be able to find the answers. So my bottom part is 9. It's 9 feet. Now I know that if across the top, if I made a dotted line to make it congruent, it would have to equal 9. But I have a 3 and I have a 2 on top of the smaller steps. Together, those equal 5. Again, I want it to be congruent, so it must equal 9. 4 plus 5 is equal to 9. So that's how I know it's 4 at the top. I do the same thing with the left and the right. I'm looking at how to make them congruent. When I'm seeing there's 3 feet plus 2 feet plus 2 feet, well, I know I'm on the right track, which is nice. And I know that with some simple addition, I could find my total perimeter of 32 feet. Notice it's not squared. It's just 32 feet. And that's right, I added it all up. So now it's my turn to decide how I want to split these up. I'm going to do 3, I guess technically 2 rectangles and a square. Because that bottom little nub, it has 2 multiplied by 2, which is 4. Now it's 3 multiplied by 4, which is equal to 12. And 4 multiplied by 7, which is equal to 28. I add it all up. 28 plus 4 plus 12. So it's going to be 44 because I have 40 plus 4, which is 44 feet squared. That's my final answer for the area. And that's page 78.